A student adds 50 grams of metal at 100 degrees Celsius into 100 grams of water at 25 degrees Celsius. The final temperature of the water is 30 degrees Celsius. Assume no heat is lost to the surroundings and the specific heat of water is 4.18. What is the specific heat of the metal? Leave a comment if you think you know the answer. Here's a sketch of what's happening, and the metal is put into this water. The metal is warmer than the water, so it's losing heat to that water. The heat transfer will stop once these two reach the same temperature, and that's reached at 30 degrees as shown by the thermometer here. Anytime you're dealing with specific heat, you need to be thinking about this equation, Q equals MC delta T. And we're trying to find the C, which is the specific heat of the metal, which means we need to use the mass of the metal and the heat that the metal lost, and the change in temperature that occurred to the metal. We're given the mass of the metal, which is 50 grams, and since the heat transfer stopped at 30 degrees, then we can find our delta T by finding the difference between the metal's original temperature, which was 100, and its final temperature, which is 30, so that delta T is 70 degrees. To find the heat that the metal lost, we need to find the heat that the water gained, because the heat that the water gained is equal to the heat that the metal lost. And technically, I should be using a negative sign for the heat that the metal lost, but I'm going to ignore the sign conventions because I don't think it changes how you should be thinking about this problem. To find the Q of the water, you need to set up Q equals MCAT for the water. So Q is equal to the mass of the water, which is 100 grams, times the specific heat, which is 4.18, which we're going to round to 4.2, times delta T, which the water started at 25 degrees Celsius and ended at 30, so that's just 5. And we'll do this problem in 2 steps. So 100 times 4.2 is 420. 420 times 5 is our final problem, and that equals 2,100 joules. So that's the heat gained by the water, which is the heat lost by the metal. So we can go back up here and plug in 2,100 equals the weight of the metal times the specific heat of the metal times the delta T that happened to the metal. So 2,100 equals 50 times C times 70. So 2,100 equals 3,500 times C. C equals 2,100 divided by 3,500, which I will just simplify to 21 over 35. And remember, you can round on the MCAT, so I'm going to change that to 20 over 35. That simplifies to 4 over 7, and I know 4 divided by 8 is 1/2, so 4 over 7 has to be more than 1/2, but somewhat close to 0.5, which means I can reasonably choose option B as my answer.